Hey mathematicians. Today for Algebra 2, we're going to work on the lesson called nth roots. This actually comes from lesson 6-4, so if you have your green workbook at home and you wanted to look at it, you can. Today I'm also going to send you guys the link to the online textbook. It's very, very difficult to load. Some computers that have a little bit less memory on them and some slower Wi-Fi's probably won't be able to access the online textbook even. Um, I feel like I have pretty fast Wi-Fi, but I can't even download it all the time. Sometimes it just will just load and load and you can't see all the pages because you guys know how big your the big textbook is. So that's actually what you guys would get a copy of. But I'll send it to you and I'll see if you guys can actually use it. So nonetheless, I'm going to go ahead and give you your notes for today. I would like you guys to write this down. So just in your notebook, or if you guys are printing the screens, you guys are welcome to do that. But this is just really short right here. Today's lesson is going to have a lot of information on it. Not as many examples. You'll still get your examples, but today is really kind of like an introduction to something that we should be talking about. I wanted to talk about with you guys at the beginning of the year. But for some reason, this lesson always gets pushed back to quarter 3, quarter 4. So this is where we are. That's why it's chapter 6. So a couple things to think about. Right here, I want you guys to write this. Where's mine? Here we go. I want you guys to look at this radical right here. Let's see. I don't know if you guys can see this. I want you guys to look at this symbol right here. And you can see that it looks like a square root. But the symbol right here is actually what we call a radical. I know you guys have heard me say that before. It's radical. So the actual symbol that looks like a check mark is your radical sign. The number that's inside of it is your radicand. So, because it's radical and you can, so it's your radicand. So it's your radicand goes on the inside. And then the little number that goes out here, the little tiny one is kind of like inside the check mark, right? Inside the radical, that's called your index. And so if you see an n, or if I ever refer to something as the nth root, it just means like whatever that little number is. And we're going to talk about that in just a minute. Just a couple bits of information I want to give you guys about that. So I have a few slides here that are just about information, and then I'll give you guys a few examples. The good thing about today's lesson, even though it's a lot of vocabulary and just kind of making sure you understand the basics, is that the examples, once we get to them, are very, very short. So you'll like that. Okay, let's go ahead and move forward. Make sure you did write this down. You can pause the video and do so. Okay, so I want to give you guys a couple of reminders here. Okay, let's see. Change it to my pen. A couple reminders. Okay, so the first thing I need you guys to remember is that this is the same as this. I don't know if you guys know that. So if you ever see a symbol that looks like this, without a number inside, doesn't have an index, it automatically has an index. It automatically has one. It's 2. That's why we call it a square root. We generally call it a square root, so because of the word square, we're thinking about the fact that we're going to use the number 2. Okay, and so because of that, we don't usually write it, just like if we had like x. We don't usually write to the power of 1, we just know it's x, right? If this is 2, we don't usually write 2 to the power of 1, we just write 2. So it's just kind of like a given that if it doesn't have a number, it doesn't have an index, it's automatically 2. Okay, but you will see it as it gets higher. You will see this radical symbol with a 3 that's on your calculator. And then you have the fancy button that doesn't have a number at all. It has the nth root, or it has an x or a y here. So that just means you can change it to whatever you want. So I just want to go over that a little bit more. So another thing I want you guys to remember is, let's see, let me switch it to pen. Let me go back and make sure. There we go. Okay, so another thing I want you guys to remember, this is the first thing, and the second thing is that remember that this is the inverse, and we worked on this last week when we were working on square roots, when we were working on exponential functions, is the inverse of x squared, right? Remember that if you want to solve for x squared, you just take the square root of it, right? So remember that if you wanted to solve for x to the power 3, you take the third root of it, right? If you wanted to solve for x to the power 4, you take the fourth root of it, right? So that's just a little refresher. Make sure that you know that. This right here, it looks kind of silly. If you're having trouble with your calculator, you need to let me know. I can help you. You are welcome to get on the video camera and we can look at your calculator and we can try to figure out what button it is, because most of you guys do have scientific calculators or you have some kind of phone that has it on it. You also have the internet, so you have a lot of options available to you. I found this Captain Calculator. It's kind of silly, but you can change the index. You can change the little number inside of the radical and you can calculate it for you. So we can definitely use that. You guys can use that in case just for now and if you don't want to ask me or whatever. So that's something that you guys can use if you're having trouble with your calculator or your phone as a calculator. So those are just a couple of things I wanted you guys to remember, okay? All right, so let's go forward. So right here, I want you guys to jot this down, and you guys just want you to follow along with me here. Okay. So a couple of things I'm going to write here for you guys. So let's say you have this power right here, x squared is equal to 36. Okay, we know the factors of 36 are 6 times 6, right? You know there's two numbers that are the same. When you multiply them, you get that 36. And the way you can say it is like whenever you solve it, 6 is the square root of 36. So for example, I'm going to write it with the 2 just so you remember. Well, no, actually, I'm not going to write it with the 2. I think it'll make more sense if we just do it like this. So this is a few different ways to write it. You can think about, okay, well, if I want to solve for x, I'm going to square root both sides. When I think about 36, you can always think of it as 6 times 6. Right, it's equal, so it's the same thing. Another way you can look at 6 times 6 is 6 squared, because isn't 6 squared 36? What's the square root of 36? 6. So just different ways to look at the same type of problem. And this is a square root, so remember there's a little baby 2 in there, you just don't see it. Okay, here's another one. We're going to increase our power. So let's say we have x to the power 3, and let's say this is equal to 64. So if we were going to solve this, we would take the cube root of 64 as well. So this is one of those things you guys could do if you're not sure of your factors of 64. You could go to Captain Calculator. You could say, okay, what are 3 numbers that multiply to give me 64? Well, when I did that on my calculator, I got 4 times 4 times 4. And you can just mess around on your calculator until you figure it out. No big deal. Guess and check. So it says 4 is a cube root of 64. So if you wanted to write it out with, because we know that a cube root, oh, my 3 disappeared. We have x to the power 3. You can write it as a cube root, and you can look at the 4 as 4 times 4 times 4, which is really 64. So 4 times 4 times 4 is also 64. But if you take the cube root of it, because there's 3 of them, you're going to be left with just one of them. My numbers are disappearing. Okay, so remember, if you take the cube root of something that has 3 of them, you get left with just 1. That's the whole point of doing it. Let's go over here. Let's increase it to x to the power 4. And I'm giving you a larger number, 625. Once again, you can check on your calculator. What's the fourth root of 625? Well, probably it's going to be something with a 5 in it, right? So that's true. So you could try 5. 5 times 5 is 25 times another 5 times another 5. There should be 4 of these, and these should give you 625. Okay, you can guess and check with that on your calculator. So we want to take the fourth root of 625, which is also the same as 5 to the power of 4. Since there are 4 of them, you're going to end up with just one of them when you take the fourth root of it. So it just basically simplifies it. It breaks it down. All right, let's try x to the power of 5. This one's a little bit smaller. Let's try 32. So now you're thinking, okay, what 5 numbers are the same which can give me 32? Well, use your handy dandy calculator. 2 will work. 2 times 2 is 4, times 2 is 8, times 2 is 16, times another 2 is 32. So in this case, 5 2's will give you 32. So 2 is the fifth root of 32. So you can, instead of writing 32, you guys can write down 2 to the power of 5. If we want to find the fifth root of it, we know we're just going to be left with 2. And that's how it works. It's the whole purpose of doing it. It's kind of like they kind of like cross out. You kind of think of it like that, right? They kind of simplify out and you just get left with just a single. So here's where that nth root comes into play. So this is just the general rule for any of these. Nth just means like any of them. Okay, so if you have the x to the power of n, you can look at it like, well, that's really x times x times x times however many more, whatever, is equal to some number. We can call that number b. Okay, so when you kind of think of it like this, you're like, okay, well, the nth root of this x to the nth power is just going to give me x, right? Because those n's are going to cancel. And that's kind of where that comes. It's just the same rule. It just means no matter what the power is, just go ahead and take that power, the root of that power, and you get the single, okay? It's one of the ways I kind of think about it. Okay, so just make sure that you kind of understand the reason why you do it is just to break it down to get the single number. And we're going to write them out like that. I feel like it's easier for you guys sometimes to do that. And these numbers just came from guessing and checking, okay? All right, so let's do a couple other pieces of information and then we got to get moving. So what's a principal root? I'm going to give you guys a definition for this. So you guys know that the square root of 25 is equal to 5. That is what we call a principal square root. And you guys know that right off the bat. I say, what's the square root of 25? You guys say principal. It is spelled like that. Square root. You guys know that. If I say, what's the square root of 25? You guys say 5, right? It's the principal square root. So if you think about it like this, what if we say, okay, what's the negative of the square root of 25? Well, you know the square root of 25 is 5. There's a negative out there, so it's going to kind of hang, okay? So this is really what we'll call it the opposite of the principal. Square root. And then let's try one more. This one wants to get both solutions, right? You want a positive and a negative 5. So we'll just call that both square roots. You want the principal and you also want the opposite of the principal, so both square roots. So just kind of be on the lookout that if you see that negative in front, don't forget to carry it in, okay? And if you don't see the negative, you can just use it as just the principal, just as the positive, okay? Okay, just as a little reminder for you guys. All right, let's keep on moving on. All right, so I have a couple examples I want to give you guys. Here's the first one, example 1. This example is, let's simplify. Let's get both. Looks like this is a square root 16y to the 4th power. So I put the steps on here for you guys. Rewrite as an nth or whatever power is given. Okay, so let's go ahead and do that first. So it looks like I don't see a number inside of my radical right here. So because I don't see a number, remember this is a 2 or a square root, right? If you don't see a number, it's automatically a square root. Sometimes that little tiny number in there is a 3 or a 4 or a 5 or a 6 or whatever it is, it doesn't matter. This one doesn't have a number, it's automatically 2, okay, because it's a square root, and you guys have been trained your whole lives to call it a square root, so that's why. So we write it as the nth or power given, so we have to rewrite this as the numbers to the second power. So one thing you could do is kind of think of it like, okay, well, what number, like what's the square root of 16? 4, right? So 4 squared is 16. You see how I rewrote it to the second power? 16 is the same as 4 squared, I can do the y squared the same way, or the y to the fourth. I can do that the same way. I can write it like this. Because isn't y squared to the second power y to the fourth? Yeah, it is the same thing. Y squared to the second power is y to the fourth. So you can do that. So step 3 says simplify without the powers. So once you take the square root of it, you don't need to write those powers up there. You can just break it down to plus or minus 4, which was the number right here, y squared. You just get rid of those powers, okay? And that's how you can simplify it. It's like the fastest way I can think of explaining it. All right, let's do another one. Let's do example 2. All right, so this one is, we're going to do a fourth root over here. So we're going to do fourth root. We just want the principal root. I don't have plus or minus. And this is also 16. I think I have g to the 16th power and h to the 24th power here. All right, so I want you guys to be thinking, okay, we're going to rewrite this 16 with a number to the fourth power. So you can always use Captain Calculator. You can use your calculator and you can try to figure out, okay, what number times it's off 4 times will give you 16. Well, 2 to the fourth will give us 16. You can also check it on your calculator, okay? So 2 to the fourth will also give us 16. You can do the same thing with g. I know that if I take g to the fourth and I multiply it times the power of 4, that's also going to give me g to the 16th power. And I can do the same thing with h. I don't know if you guys can catch on what I'm doing here. One thing that I did do was I divided 16 divided by 4, and I got 4. Do the same thing with h. 24 divided by 4 is 6. And look at that. Isn't that cool? 6 times 4 is 24. 4 times 4 is 16. And 2 to the fourth power is 16. So it worked out. So I rewrote it as whatever the power was. Okay, and you can use a calculator if you need to, no big deal. There's no judgment, right? You're at home, so this is a judgment-free zone. Not that you would be judged in classroom, whatever classroom. I used to be at 178. It's been so long, it feels. Okay, so then go ahead and simplify it without the power. So all you have left is 2g to the fourth, h to the sixth, and that's it. That's all you gotta do. The power of 4s are removed, okay? So that's all you have to do for these. So just try to rewrite them to whatever power the index is and then take them away, all right? Just one way to reduce it. So let's go to the next one. I want you guys to try the next two. This one is this example right here, I want you guys to try is to get both of them. Just make sure you bring it down. We're gonna do the square root of 36, x to the 10th power. I want you guys to go ahead and work on that one. So take a minute, see if you can rewrite this to the power of 2 and use a calculator if necessary. Okay, I'll pause it for just a moment. Okay, so hopefully you guys were able to think, okay, we know we did this before. 36 is the same as 6 squared, right? And you can divide 10 divided by 2, because remember that's a square root, right? The square root, you don't see it, but that 2 is there. Okay, so you can do the same thing. And you can take x to the 10th power divided by 2. That's going to be x to the 5th. And look, now everything is to the second power. Since everything is to the second power, you can remove all of those fancy powers that you see. And that's all you have to do. Okay, hopefully you guys are just getting used to rewriting it so you can take those powers away. So you're simplifying it. Okay, I'm going to give you guys one more to try over here. And then I'll give you guys your classwork. You see how long the lesson was, but how quick the problems are to solve, hopefully. This one is a 5th root. Don't worry. That number's a little bit bigger, but that's okay. I really want you guys practicing your calculator on these and just playing around with it until you get the right answer, because everyone has a different kind of calculator. I know. I was getting really good, and then now I'm not with you guys, and now I can't help you with it. So take a minute and try to figure out, okay, I need a 5th root, so I need 5 numbers that are the same that multiply to give me 243. And we have a to the 20th power, b to the 25th power. See if you can break these down, writing them all these three factors to the power of 5, okay? Take a moment, try to figure that one out. All right, so hopefully you guys took a moment and you were trying to figure out what number, how can I break down 243? Well, it's actually not as bad after you probably try to play with it a little bit. So 3 times 3 times 3 times 3 times 3 should give you 243. If you divide 20 by 5, you guys should get a to the 4th power. And a to the 4th to the power of 5 gives you a20. And also b, you can break b down, hopefully power of 5. I think it's kind of cool that you can kind of manipulate these numbers, and look, they all now have a power of 5. We did not change the value of any of these, we just rewrote them. And then last step is to simplify without any power. So you ended up with just 3a to the 4th, b to the 5th. And then you're done with that. That's it. So it wasn't too bad calculating. Just go through these examples. The problems I gave you guys today are pretty similar to these problems right here. Sorry the lesson was a little bit longer, but I just really wanted to give you that background information and try to scaffold as much as I can and give you as much as I can, you know. So let me go to the next screen. These are the problems for you guys to work on today, just 5 of them. I want you guys to send them to me either as a Word document, a PDF file. It's probably easier to just do it on notebook paper or in your notebook like I do. I've been using a notebook. I've just been, no foldables, just a plain old notebook, and just take a picture of it and send it in through your team apps. What I would do. I just think that's the fastest way. So go ahead and try to work on these and send it to me today so you guys get credit for trying, and then check your answers tomorrow. All right, guys, I hope you have a fabulous day and get to working on these radicals. And I know that you guys radicand. All right, I'll see you later. Bye, guys.